One of the key benefits of using WOTS is the ability to quickly identify underperforming test operations and your most frequent failures. And in this video, I will demonstrate how to identify the worst performer among my top runners, then identify the steps that cause the most failures and try to diagnose the most failing issue. So I'll start by entering the reporting module. And here I'll be using the yield report. I'll be using a blank filter. And in this case, I'm looking at this month's data, meaning last 24 days of data. So I'll apply the filter, and this will give me a list of all my tested products. And it will give me one row for each combination of part number and test operation. So in this case, my top runner is this 277288 in a test operation PCBA test. And it's tested almost 5,000 units for this time period. But I can immediately see from the green yield metrics that this test is performing well. So I will go ahead and look at some of the other ones. And using these yield metric colors, I can quickly identify my worst performers. And I can see that the second on the list, with 800 units tested, has a yield of 79.8%, meaning that out of these 800, 2 out of 10 will fail the first test. So I want to investigate this test more in detail. And to do that, I will use the drill down menu. And here I can go to any report of the system. But in this case, I will choose the test step yield and analysis report. And once this report loads, it will show me all the different software runs that has been run in the period for this part number. And we can see that there are 3 of them. And you can see the software file name, software version, and product revision. And you can also see the number of tests performed. And you can see here that this one is only 1 unit tested, and this has 4, and they are all prior to August 11th. So in this case, I want to look at this one. It's the one that is tested most recently and with the most volume. So I'll select it and apply selected, and this will load the report showing me 2 different Paretos. The first one is the execution time. I will skip that and we'll go directly to the top 10 failures. This shows me the 10 failures that failed the most for this test operation in the time period we are looking at. And to the left, I can see the most failing one. So out of all these failures, the measure T101 voltage has 36 failures and accounts for 22.6% of all failures. So fixing this issue will have a huge impact on the performance of this test. So I can go and look into that test, that step in detail by clicking this bar or clicking the name in this top 10 list. And this will open the step details view. And in this view, you can look at the actual measurement data. To the left, you will see a list of the entire test sequence. I will hide that to give you some more screen space, and we'll focus on this measurement chart in the bottom of the screen. Here I can see the top and low limit. I can see the average and the distribution of the measurements, and we can see immediately that the distribution is to the low end, close to the low limit. We can also see that most of the failures that occurs in this region against the low limit. But we also have some failures against the top limit and lower limit here, and we also have one in the end here. So what I can do in this view to investigate this closer is to separate these measurements down to different header properties. So I can go to the group by and look at, for instance, how does this look across different test stations. This will give me different color lines for different stations, and we can see that there are 3 different stations in use in this test, and we get more or less the same failures across different stations. So let's look at another property. Let's look at the fixture ID. And here we can see something interesting. Here we can see that it looks like all the failures are related to this number 3 fixture, which leads me to think that this fixture should be investigated. Maybe the problem is not related to the unit that's tested, but to lack of maintenance or calibration for this 709 523 26 3 fixture.